Okay. And so we have another problem, and this problem is pretty hefty. So I'm gonna skip going through this for now, but this is more practice for limiting reagents. Okay, more limiting reagent practice. So try this on your own, okay? Definitely you should try this on your own. The notes are going to be available for you to calculate this. But what I also wanted to show you, the additional problem with this is now this whole idea of percent yield. What is yield? Okay. So if I back up to this thing, and let me go to this, okay? So suppose I do this thing, right, with the 3 hams and the 1 cheese and the 1 bun, and it makes exactly 1 ham and cheese sandwich. 100% yield. That means I didn't waste any reagents, okay? That means everything was consumed perfectly and made exactly what I was expecting. This is still a 100% yield. I just had leftover ham and cheese, okay? But for example, if let's say in the process of making this, somebody took a bite out of this thing before we were making it, it would obviously no longer be like 100% yield because somebody consumed some of it, okay? So often in chemistry, we never get to 100% yield. So often you never get 100%. There are side reactions. There are impurities. There are other factors that lead to reactions not giving you 100%. Okay? So what is this difference between actual yield and theoretical yield? Well, actual yield is what you made, what actually got made, and the theoretical is what you calculated should be made. What you calculated. So all of this stuff that we've done up to now has only been theoretical yield, okay? So for example, I'm just gonna, you read through the problem and you'll see that you can get a reaction set up, and that reaction looks like this. CO gas, 2 hydrogen gases, and that makes CH3OH liquid. And the way this problem goes is it says, well, if you had 68.5 kilograms of this, 68.5 kilograms of carbon monoxide, and 8.6 kilograms of hydrogen, how much of this could you make? Okay, so I'm not going to do this in this lecture, but you can follow those exact other 2 examples that we did. Okay, and I'll tell you the answer that you get. So I'll say this one is number 1 and this one's number 2. So from number 1, from the carbon monoxide, you get 7.84 times 10 to the 4th grams of methanol. And from the hydrogen, you get 6.83 times 10 to the 4th grams of methanol. So which one is the maximum? Which one's the most that we can make? It's the 6.83 times 10 to the 4th grams, right? That's the one, that's the most. The least is the most, okay? And this is what we would call our theoretical yield, okay? We calculated it. We didn't actually do the measurement. We calculated it. But then now look what this problem says. This problem says if 3.57 times 10 to the 4th grams of methanol is actually produced, actually being that key word, then what's the percent yield? Okay, well, actual over theoretical times 100. So it would be 3.57 times 10 to the fourth grams all over, let's see, oh, the theoretical, there it is, 6.83 times 10 to the fourth grams times, 100 to make it a percent. I get 52.3% yield. So let's do that here in the calculator, right? So I can say 3.57 e to the fourth equals divided by 6.83 e to the fourth equals, and then as soon as I say equals, it's going to spit out the answer. So that's 0.52269 something. Remember, times 100 to make it a percent. So 52.3% with 3 sig figs. Okay, folks?